So this video is about Avogadro number. So before that, you should know that for this chapter, you have to know what is the meaning of mole, because it is going to talk about mole first, and then we have the Avogadro constant and Avogadro number. Okay. And to begin with, I would like to mention this one will be 6.023 times 10 to the power 23. This is known as the Avogadro number. Okay, and what is the meaning of that? So let's begin with a very simple example. When we mention we have 1 mole of carbon, okay, we know that we have 12 grams. Now, okay, I hope that you should understand this meaning. But when we mention there are 2 moles of carbon, okay, you also know that it is 24.0 grams. Okay, then you can move on with this video. Okay, so the definition of Avogadro number, or the constant, actually this one we can also name it to be the constant. And if we talk about 1 mole of carbon, okay, 1 mole of carbon, we are actually talking about this amount of the carbon atom. Okay, in this case, carbon atom. Okay, and then you know that, okay, if we have 2 mole of carbon, the calculation will be like 6.023 times this one, and then times 2 atom. And according to the calculator, then you will have this value. Okay, so normally we consider 3 significant figures. And now, okay, if you understand this meaning, then you should know that this concept is universal. Okay, that means if you have 1 mole of, okay, helium, then you will have 0.23 times 10 to the power 23, like this one, helium atom. Okay, and if you are talking about, okay, 1 mole of nitrogen, okay, then you still have this one. But hereby, I would like to ask you to pay attention to the term now. When we mention, okay, the term atom, okay, the term atom, it corresponds to 1 atom. But for molecule, that is 2 or more atoms together, when they are chemically bound or joined together, then that will be a molecule. Okay, that is why you have to pay attention to the question. If you're going to find out the number of particles, then you're actually going to consider the number of molecule. Okay, and sometimes you only have 1 atom, so that is what we call the monoatomic. Okay, monoatomic molecule. Okay, so the simple example will be carbon, helium, argon. They are existing as 1 single atom. But if we are talking about something like the oxygen, nitrogen, chlorine, and something else, if they form by 2 atoms, then that is what we call the diatomic molecule. But no matter what, when you are going to find out the number of particles, you just have to consider the number of mole, okay, number of mole times this Avogadro constant or number. Okay, it's very straightforward. But then, for some question that you can see, okay, in your notes, now let's look at this one as the example. Again, if we have 1 mole of, okay, hydrogen, okay, hydrogen molecule, you should know that if we do the counting, we have 6.023 times 10 to the power 23, okay, hydrogen molecule. But if we are asking about the atom of hydrogen, then this one will become this value, okay, this value. So after the calculation, you can also find out that you will have this 1.2 times 10 to the power 24 hydrogen atom. So This is the main difference that you should understand. Okay, hydrogen molecule here, but for atom you will have this value. Okay, this value. And after this covalent compound, I'm going to show you one more ionic compound. So for example, again, if we are talking about 1 mole of sodium chloride, you will know that we will actually have 6.023 times 10 to the power 23 sodium chloride. Okay, this compound. But this is an ionic compound, as you can see. How about if I ask you how many ions are there? Okay, actually there will be 1 mole of sodium chloride, then you will have 6.023 times 10 to the power 23 sodium ion. Okay, or you will have 6.023 times 10 to the power 23 chloride ion. But this is very tricky here. You should know will be, if we talk about ions only, you can't just put down like that. You have to have this tricky point times 2, which will give you 1.20 times 10 to the power 24 ions. Okay, here. Okay, is it clear? So one more example. Okay, if we have sodium chloride, maybe I also showed you 1 mole of sodium oxide, so that you know, if we consider it like this, you will have this number. This is the compound. Okay, this is the compound. But if we are talking about this, and then consider the cation, that means the sodium ion, then this time you have to times it by 2. And for the last one, here I also change it back to the value so that you can follow. And for for the oxygen, you know this is what you have. Okay, this is what you have. So pay attention to this. And last one will be, some of you ask, when do I know? Is it molecule or atom or ionic compound? That means ion. So basically, remember what you have learned. When you have metal and non-metal, then that must be ionic. Okay, ionic. While if you just consider long metal, that must be molecule. Okay, but if you are talking about group 0, or group 8, then that one will be atom only. Okay, is it clear? So to make it simple, we will look like this. Now you have 2 sets. You have ionic or molecule, but atom is one set of that. That is why, just check it out. You can have helium, neon, argon, carbon, sulfur, and then for others, probably you will find that to be H2, N2, CO2, O2, F2, something else like this. So that's the end of this video.